Today we'll be simulating a bat hitting a ball using solution 402. We'll begin by creating a new part file where we'll create our geometry. First we'll create a small section of the bat where the bat will be hitting the ball. Here we'll create a cylinder. And we'll say that the bat will hit the ball at about 18 inches out from the center of rotation of the bat. Next we'll make the ball, and we'll put that slightly in front of the bat. Next we'll assign a material to the bat and the ball. We could assign separate materials if we wanted to, but here I'll just assign the same material. Next we'll create our simulation models. Since we don't need to idealize the geometry, we'll turn off Create Idealize part. Then we'll create our solution 402. And here we'll specify our output requests. Here we'll disable everything except for contact and displacements. Here we can see a preview to confirm that we have contact and displacement selected. Next we'll go to the parameters where we'll specify large displacements. Next we'll create a nonlinear dynamics subcase, so that will account for the inertia, and we'll specify an end time of 6 milliseconds with 20 increments, and we want output at all times. This way, if the solution does need to bisect in order to capture the contact, we'll see those results of the contact in our results. Next we'll go ahead and put a mesh on our geometry. That looks good. Next we'll define the center of rotation of our bat by creating an RBE2 spider point to face, where the point will be at 0, 0, 0, and we'll connect that to the face of the section of our bat. Next we'll go to the sim where we'll specify some constraints. We'll go ahead and fix all degrees of freedom of that point except for rotations about Z, and that's how we'll be swinging the bat. And we'll swing it by applying a moment of 3,000 inch-pounds. Alright, and lastly we'll specify our contact between the bat and the ball using the manual method. First we'll specify the face of the bat. And the face of the ball, we can see it's split in two halves, so we'll make sure we get both halves for both faces there. And then our mid-search distance, I'll specify that as half of the global element size. And we're ready to solve. Now, if you're not sure how many increments to specify and what time step, one thing that you can use to monitor the solution to see how much the bat is moving for each of the increments is the solution monitor. So this will give you some idea of, do I have the right time step? And we don't want to be moving more than half of the global element size when we're about to contact to make sure that we're capturing that contact. And here I'm pausing the video. You can see over on the right hand side the total elapsed time for the solution was a little over 2 minutes. And then we're ready to look at our results. The first result we'll take a look at will be our displacements. And we'll go ahead and animate that across our iterations. And let's get a good view of that. So there we can see the bat swinging and impacting the ball. Next, what we can do is manually step through until we're just about to contact the ball. And here we can see that's at increment 18. Then we can take a look at our contact pressure results and see what that looks like where the ball and the bat are contacting. And that's how to simulate a bat hitting a ball with solution 402 nonlinear dynamics with contact.